the college management, HOD of the department, giving me this opportunity to share my knowledge with you. So we are all teachers, and we have to update our knowledge every day. So my background is, I am also alumni of VTU. I studied my MTech in MC Hassan, did my project in LRD, Signal Processing Lab. Okay. Then there was no industry job. Then I switched over to teaching. And on the way, I found Bedam Subramaniam, the author of Power Electronics. Many books has written on power electronics and drives. So he encouraged me to do PhD. And he asked, you come and sit in my class. Then I started learning drives. So he taught me vector control. Then he told me now DTC, direct torque control, is very popular. You have to work on that. So that time FPGA VHDL programming was very hot topic. So in the signal processing lab, I acquired that knowledge. Then he said DTC control you have to implement in FPGA. With that, I started my PhD in JNTU Hyderabad. And Bedam sir was my co-guide, and guide was Dr. Tulasiram Das sir. He was former VC of JNTU Kakinada and principal of JNTU Hyderabad. So with that, I started my career. Then I got the opportunity to work in V8 University for 10 years. And they have very good laboratory, other things. Then I am able to explore, okay, myself. So from drives, then I said, since I am a teacher, I have to be a professor, then do some good research. Then I switch over to this field, power electronics. So then after some time, power electronics got saturated. Then I thought, how will apply power electronics in other fields? Then I applied one project to DST on renewable energy. So solar energy application on power electronics. So I got a project on that. That is around 45 lakhs, that project. So after getting that project, I took some PhD students and they did some work. So whatever work they have done, I'm going to present over here. So my topic is power electronics, but I will start with what is the status, EV status, why we are going for EV, why most of the projects and all this, ATL, everything is getting accepted if your topic is in this field. Okay. So we'll start with this, why there is a climate change. Okay. So you can read this book, and after reading this book, you will take interest to work on electric vehicle, okay, or in power electronics if you are electrical engineer or any other engineering. So now you see our animal population from 1970 to 2020, how it is declining. So what is the reason for that? Reason is climate change. So now, by 2030, we are planning to mitigate this climate change, 2030 to 2050. Okay. So what are the steps government is going to take, and in which field you should do your research, so that by 2030 we should meet it. So he is the Secretary General and CEO of WWF, Nature India. So many articles he has written on this, what is the next step we have to do, so that we'll meet our requirement. So this is the climate change. So when I was in Bangalore, from Majestic to Marathali, I was going by bicycle. And only one car, Reba car, red color, I have seen on the road. But now after 23 years, from 2000 to 2023 now, it took 23 years time to see some more electric vehicles. That means we are not doing anything for climate change. So now what are the causes and effects of climate change? Industry, everywhere you will find industries, energy use, agricultural practice, deforestation. So all these are the effects. Rising temperature, rising sea level. So everyone is aware of that. But who is responsible for this? these fuel companies, all these Chinese and European country, or these politicians or rich people, Adani, Ambani. So who is responsible for this? So all of us are responsible for this. We never encourage our student in the class, you should do your project in EV, not your conventional things, simulation of power system, okay? So we are responsible for that. Whenever you take a PhD student, you should ask him to work on climate change. It may be any field of engineering, you should encourage him to do that. So when I started my PhD, there are only few journals, machine design or electrical machine simulation or power electronics like that. But nowadays you see many journals in Elsevier's and IEEE on climate change. Why many journals? Because that is the field you should do research. So specifically they are making solar energy journal or wind energy journal like that. So now these are the climate change. This is the pressure on government from United Nations. So you should work on this field. So we are interested in this electric vehicle, the third one. So that is our work to encourage our students. We should publish more review papers. What are the problem with IC engines? Everyone knows. They generate toxic gas, generate waste, heat, all this. So we can, while going on the road, we are able to see all this. But electric vehicle, no environmental problem at all. But some researcher in IIT, I think Kharagpur IIT or some professor, he said, electric vehicle also not good because concept is good, but we cannot recycle. The tires, the battery, how will recycle it? Where you are going to recycle? Same pollution it will generate. So whenever you are giving one idea, one concept, first thing you have to think also how to recycle that. If you are not recycling, then that will not work. So these are the advantages with electric vehicle. So it's very simple. Electric vehicle is not new. In 18th century also people they used electric vehicle. That time battery was there, DC motor was there, they connect. But after some time what happens? Electric vehicle disappeared. The reason is this petrol diesel has performance wise, if you see, those are better. But after some year we found that no, there is a lot of problems, okay, emission problems, greenhouse gas you reduce, then mitigate the climate change, all this. So again, this has been introduced. So, but nowadays we have many technology, we are talking about AI, machine learning, all this. So if you are applying all this system is very complicated. So it's not very simple like one battery, controller and motor and two wheels. So we have many things to do on that. As the chief guest said, there is no noise. No noise means very danger. We don't know who is coming from back. But I have seen in Ola scooty, they put the music. Okay. So music will be running and driver will be driving the vehicle. And I have seen that music, you can listen only for some distance, not much distance. That speaker has been designed in such a way that it won't make many noise like big speakers. Okay, so that is the technology. So that's music means it is some noise you are getting. Okay, Ola is coming back. You are able to know that. So that is one solution, innovative solution. Putting music through your Spotify smartphone. So the next, if we think little bit more, then AC machine has come. Okay, you have the controller, that one potentiometer you can use. Just you press that potentiometer, resistance will vary, speed will vary. Okay, so you can run as a drive, like your rheostat control in induction motor experiment. So after that, again we have some DSP processors, microcontroller, microprocessor has come. Then they develop some more things. So you have power electronics. then your induction motors. So now little advanced, then some display, at what speed you are running, all this you are able to see. But that is the during 1980s. But present day, if you see the car, this is like this. Many things you have to do because that is a requirement. Okay, there should be airbag. To open the airbag, you need energy, engine control, front light, mobile charger, everything is required. For all these things, electricity is required. From here you will get this electricity, this much power. So battery technology has to be improved, but we don't have such battery technology right now. You cannot power so many things together. So that is the problem. But there is a pressure, global pressure, that at any cost you have to adopt electric vehicle. There is no other options. If you want to travel, you have to use only electric vehicle. So 13 years before I visited Singapore, Malaysia, Thailand, all this. So I have seen electric vehicles over there, many on the road. But those days in India, we will not find such electric vehicles. Some country they adopted, but Indians are not adopted. Here population is more, but they are not adopting. So such policy you have to bring, and government has initiated all this. In Odisha government, they said, if you are buying an electric car, 15% discount will provide for you. But nobody is buying. Because the electric vehicle has many demerits where you will charge. Okay, we don't have charging stations. Then charging per unit, how much I have to pay, all this. So yesterday I was in my friend's house. He is not paying electricity, he said. In Karnataka, no electricity bill, I think. But he is paying water bill 1,500 rupees. Then I surprised. So which policy it is? So that is why policy is very, very important. I'm paying for water, but not for electricity. So where our society is going? So government has made all this, and this price has been declined because of technology advancement. So this is the global stock electric vehicle. You can see that in China. Okay, this much million by 2020 they are investing. Okay, stock. So China is better among all other countries, China and USA. What about India? India is not there, but it is a big country. Okay, so why it is not there, India? Then these are the company to manufacturing of electric vehicle. So by 2030, they are planning for 100%. Okay, so annual EV sale, percent of sale electric, new EV models. So they have planned like this. So by 2030, they are telling we are able to make it. But these companies are not from India. Okay. But how to boost the policy? How to encourage people to go for electric vehicle? So globally, they have some countries, they are giving some subsidies and some encouragement to use electric vehicles. But in electric vehicle, the important component is the battery. So now you see the battery, these are the battery cost structure of electric vehicle. This is cost of an EV battery cell. How much money you are spending for cathode, manufacturing process, anode, separator and electrolyte. And overall, total electric vehicle, how much, where you are spending more. So you are spending more here in battery pack, you are spending more money. Here in cathode, for battery you are spending more money. But cathode is made of some material. So from here you are getting that material, which country having that material. So that is very important. So you can see that battery cost has been drastically reduced because of technology advancement. So now from 1220 US dollar to 132 in 2021. So after a lot of research, So this many years took around 10 years took to reduce the cost of the battery. So that is why India, like poor country, they are not able to adopt electric vehicle. So now battery cost has been reduced. Now we can go for that. So now you see these are the material used for battery. Mining, material processing, cell component, battery cells, EV, which country, you can see this orange color, United States and China, these two countries. They are having this material. We don't have those material, we have to depend on those countries. But though both the countries are opposite to each other, China and USA, they never like each other. How they will cooperate so that the technological advance will be there. Okay, so in India, name is not there. We have to depend on those countries. Okay, so there are some political problems, geographical problems to design a electric vehicle. Now anything happen, any war is happening, so US will tell you have to support him, or China will tell you have to support him, otherwise we will stop manufacturing, we will stop sending this material to your country. So what will happen to our country then? So there are such issues are related for your manufacturing of electric vehicle. So now this is the complete process, upstream, midstream and downstream, from raw material extraction to the chemical processing to the cathode anode, all this till electric vehicle. There are 6 phases. So for all these 6 phases, we cannot depend on a single research lab or single country or single scientist. We have to work together for this. So if anyone is missing, then that will not happen. We cannot design the electric vehicle. So now these are the company, they are doing all this from extracting mineral to the till making of the electric vehicle. And in India, you can see that just after Corona, now it has been raised. So there are many electric vehicles everywhere you will find, and government also encouraging, and many companies like Ola, they are manufacturing many e-scooty, okay, Tata, all these people, they have now will find many electric vehicles on the road. So by 2023, we have many, and we have very good transport minister also, Nitin Gadkari ji, who is also very knowledgeous, and he is also encouraging every time to go for this. So for electric vehicle also you need very good roads. Okay. So he is keeping all these things in the mind, and he is planning by 2030 at least we will achieve our goal. The cell in India by 2023, this is 3 wheels electric vehicles, this 2-wheelers electric buses, and this is 4-wheelers cars. These are cars, these are the like 3-wheelers auto like kind of things. 2-wheelers are many. So now this is the improvement in India. So we have reached some level, and there is a possibility by 2030 it is possible. So, but we are lacking in this 0.16% only you will find in metro e-buses, okay, battery operated buses. So these are the electric vehicle across different states in India. Highest is Uttar Pradesh, and here Karnataka. So why Uttar Pradesh in the ahead? Because most of the company, manufacturing unit, everything is in Bangalore or in Karnataka. So leadership is very important again. So that is why something is happening over there. Some states are not there here at all, very less. Assam like state is going ahead. So these are the policy government has made. Okay, so before going to power electronics, I want to tell these things so that people will be encouraged to do the research on this field and to get a project even, because government is giving all these facilities, apply project to DST, solve in this field. So now here FAME 2.1 policy, PLI scheme, then battery swapping policy, duty reduction policy. So many facilities they are providing to go ahead with this. So now we have to skill development. That is the hot topic nowadays. So we have to skill our engineers, not only university certificates. So now every state having that skill development centers, we have to train. So we have to train which field, wherever is our requirement. Okay. So now how many jobs they're expecting? 10 million job opportunity by 2030. Okay. In vehicle manufacturing, charging infrastructure, by battery manufacturing, all this. Our chief guest told the same thing. So people should work in this field. Some will say, no, I am very good in electrical machine. I want to do electrical machine design. Or I want to do some power system simulation optimization technique. So that will not work. You may get published a very good paper in a good journal with impact factor. But after completing your PhD, no use. So you have to do your work where society need. What is our requirements? Then you can apply for a project once you are getting a job. So these are many players also, okay? So in domestic and international. So these are the challenges we are facing. First one is deluxe price, then power crisis, charging infrastructure, digital and economic divide, e-waste management, charging in the fuel dependency, change in fuel dependency, limited research and development, skill workforce and training. So several times, one of my friend, he did his PhD in IIT Delhi 10 years before on electric vehicle. 10 years before. But he could not do some good work, because whenever he planned contact some power electronics company, I need a converter, something like this. But they said, we don't have. We have not done any research on these power converters. Battery management system failed. So he could not complete his thesis. Took more than 7 years' time. So these are the challenges. Very few people they are doing research on this field. And we have to depend on many industries to support. But we don't have that technology. So these are some success stories and case studies. They have already proved. This company, Ola Electric, everywhere you will find that. So like this, many companies now they are success. Their manufacturing unit is going fine, and hoping by 2030 it will be 100% renewable energy in India. So investment. So like those are in political, they said now money has been invested in this field. So many researchers, many industry will come together for applying that project. So now this many US dollar, 2.9 billion US dollar for charging stations has been invested, going to be invested, okay, by 2020 to 2030. And battery, this many, EV manufacturers, this much. So there is money, so you have to target how to get some money from there as a researcher. So definitely this money will be spent for research. Okay. So this is the configuration of a drivetrain. Let's slowly come to the electric vehicle. So we have to work on electric vehicle. So this is the structure of an electric vehicle, okay, conventional one, with gear. And the prime mover may be, if it is a hybrid electric vehicle, it may be electric motor or IC engine. Then these are the classification of IC engine, and these are the classification of electric motor. But we are interested in simply electric vehicle, not hybrid electric vehicle. So you have to choose a electric motor. So electric motors, you know that since there are multidisciplinary people, so that is why I am going from very fundamentals. Motor means there are many type of motors. Okay. So which motor will be best for electric vehicle? That analysis also you have to do. So now in DC motors, these are the classifications. Then AC motors, these are the classifications. Then in AC motor, we are much interested because it has many advantages. Okay. So these are very classical motors, induction motor and synchronous motor. But these permanent motors are very popular nowadays. BLDC motor are very popular, or this reluctance motors for small applications like e-scooty. So permanent magnet bustless DC motor, permanent magnet synchronous motor, then permanent magnet hybrid motor. So those are studying advanced modeling of machines. Okay, that modeling, your vector control, director control, all this machine modeling knowledge is very much important, because in an electric vehicle, all the components are connected together. The performance of the machine, the performance of the power converter, the performance of the supply, so everything matters. So we will be thinking that, okay, we have battery, just connect, motor will run. It's not like that. You have to use some high-end softwares like MATLAB, PSIM, okay, or your ORCAD. There are many softwares to model all this. Before implementing, you have to go for modeling, simulations, all this. Once it is, you are satisfied, only you can go for actual design of the system, which cost a lot. Okay. So if you will go to all research laboratory, these softwares will be there, and you have to design the complete system. After that, only you have to go for hardware implementation. Otherwise, whatever project you got, 50 lakh or 1 crore project, simply it will be wasted in one day. So before that, they will ask, whenever you are applying a project, they will ask what are the facilities available in your college, whether you have licensed MATLAB or not, or any other PSIM or other softwares. If they are only, they will give the project. Because it will be reviewed, your project will be reviewed by one IIT professor, and he knows that to implement this project, these are the minimum things required, whether your college is having or not, whether you have published some paper before that or not. Then they will give this. So then, how much energy you spend for each component? When you are standby mode, standby ideal, then other accessories, then drive line losses, braking, rolling resistance, aerodynamic resistance. So this much of percentage of energy from total energy you are spending. Okay. Then you have to calculate how much energy I have to decide, how battery pack, what is the capacity, so that it will deliver all this energy. These are the losses only. This much losses occur in a electric vehicle. So for my vehicle, what will be the, that is called sizing of the electric vehicle. So simply you cannot take a battery, connect all this, no. So you have to calculate. So you should have the knowledge on automobile engineering. So automobile engineering people will give this idea. So now these are the different components of a electric vehicle. So this is the energy source, energy refueling unit, energy management, auxiliary power supply, temperature control, power steering. Okay, then it is given to power converter, motor, then your mechanical transmitter, and this is the driver sitting over here. Okay, so how much energy, where how much energy are going to generate, how much energy is going to consume, that idea you should have. So this is a typical configuration of a electric vehicle. Okay, these are the standard configurations for electric vehicle, different blocks. Okay, then these are the different configurations. Okay, so with gear, without gears, fixed gears. So how we are going to connect together? The motors, then gearbox, then your differential, it is connected something like this with a coupling clutch. Here it is without clutch. Here you can say the motor and the fixed gearing is on the wheel, but this is in the shaft. So that is all automobile people work, not electrical engineering people work. Automobile people has to tell in which location you are going to use, whether it is a hilly area, it is a plain area, or you are going to use in industry. So they will recommend according to their dynamic simulation of the electric vehicle, they will recommend which type will be better for you. Then you see here it is fixed gearing and motor is together in a single wheel, no shaft at all. And here the motor itself is the wheel. This is something like this. This is the starter, this is the rotor. From the battery, you are converting DC into AC, that AC is given to the 3-phase winding over here. So wheel itself is the motor. So this is already in European countries, this type of cars are already running. Okay, then unmanned vehicle also. So now you have to decide which configuration. So according to their standard, there are 6 type of configurations, F. So there are 6 type of configuration of electric vehicles. So then power source, you can use battery, you can use capacitors, you can use fuel cells, okay. Then other components like flywheels, power converters and reformers. So how will configure all this? That is also depends on your geographical condition, which area, which place, where is the application, whether it is inside the sea or in the space, okay. So accordingly you have to choose the configuration. So here also it is 6 different types according to sources, different sources. So 3 different sources, battery, capacitor, fuel cell and also flywheel. So if you will go for a typical electric vehicle, okay. So I am a power electronics engineer, I will concentrate only on power electronics. So here this is the source, grid, off-board charging, on-board charging. The charger is in the car itself. Off-board means that is in the charging station, the charger. Okay, because it's extra weight for me, so I have this charger in the, and on-board, this is also home garage in your office or in your home you want to charge it. So that is also you can give one option. That means 3 charging points, okay. One is on board, off board, and another one is from your office or home you can charge the electric vehicle. So usually AC source is supplied to the grid, okay. That AC is converted into DC because I have to charge the battery. Then AC to DC if you are converting, that is called a converter, okay. AC to DC converter or phase control rectifier, that is filtered, okay. Then again that is boosted using DC to DC converter. So there are different type of DC to DC converter, that is called chopper, okay. So in textbook you are studying all this class A chopper, class B chopper, so many types, buck boost converter, okay. So all these converters are used here. So once you are getting DC here, that DC is given to the battery bag to charge it. So this is bidirectional. So it will charge and it will also discharge to the motor. Then same DC is given to your other appliances, electronics load, your fan, AC, light, heater inside the car. So you need 2 DC to DC converter here, 1 DC to DC converter here, AC to DC converter here. Then you have motor here, that motor has to be controlled with help of a inverter, that is called DC to AC converter, or that is called an inverter. So most of the work people has to work on this. So now there are three areas. One area is you have to charge the battery. So knowledge with battery knowledge and power electronics knowledge is required. But electrical engineers doesn't know about battery. Here, this is electrical motor drives person, very familiar with vector control, director control, field oriented control, variable frequency control, AC motors, DC motors, BLDC motors, many knowledge on this. Okay. Then we have an inverter over here, power converter. Then again we have a DC to DC converter. That means this is one area along with this. Then this is one big area. Then this is another area. So you have to choose, you want to do your research on which field. Everything is not possible. Because if you will go to Science Direct or IEEE, you will get more than 5 lakhs paper in each field. Okay, only charging you will get more than 1 lakh papers. Okay, so this area is very old. But still there are a lot of problems in this area. The converting DC to AC, giving to a motor, controlling that is very difficult. So now in an electric vehicle, previously I was showing a very simple one. But now you see how complicated. So everywhere you are seeing only power electronics, nothing else. Here this is completely power electronics. Remaining thing is nothing. Wheel, 4 wheels and these charging points. That means electric vehicle means only 2 technology. One is battery, power converters. Motor you are not going to do anything. Already motors are developed. No need to do research on motor. Already BLDC motor and your permanent magnet synchronous motor, then all single phase motors has been well developed. No need to work on that field. So you have to work on power electronics and the control of power electronics. My aim is to, here this efficiency is 80%, here efficiency is 75%, here 80%, here it is 80%. I want to achieve 95%. So how to make it 95% so that from battery whatever energy I am giving to this will be more. Efficiency will be more. So now, then in power converter what you have to do? In power converter you have inductors, capacitors, switches, nothing else. Inductors, capacitors, switches. If your control technique is not good, the inductor size will be more, capacitor life will be less. So that means if you are not using that converter for 2, 3 years or 5 years, then nobody is going to use your electric vehicle. So how to increase the efficiency, decrease the cost, decrease the size, decrease the heat dissipation so that people will prefer this. So these are the problem with the power electronics. Okay, so my topic is on power electronics. So these are the power electronics converters. See, many converters are already done by the researchers. It has been classified as different types: DC to DC converter, DC to AC converter, AC to DC, then AC to AC. Okay, so we have very popular books like Bedam Subramaniam, then Rashid, then B.K. Bose. There are many books. Okay, so those books cover all these things. So what I do when it is B.Tech level project, some 2 to 3 batch will come to me. I'll tell you, take your MATLAB software or your PSIM or ORCAD, PSpice, take any one of this, simulate. Then refer some paper already published, what work they have done, try to do that. If you are not able to completely do, some part at 20% you do that work. So that is B.Tech level project will be over. If it is M.Tech level, then do it completely. Okay, you can go for a matrix converter or multi-level inverter or any optimization technique applying to a 2-level inverter, something like that. Okay. So these are the classifications I have collected from a review paper written by one of my friends. Okay. So let's go to very fundamental of power electronics because many branch of people are there. So these power converters are classified as 5 types, all like my 5 fingers. Okay. It can convert from AC to DC, DC to AC, AC to AC, AC to AC with same frequency, here change in frequency. Then DC to DC. Power electronics mean definition of power electronics is converting and controlling of electric power. You have to convert one quantity to other quantity and you have to control that power. You have to control that voltage or current. So that is called power electronics. So it has some names. If you are telling inverter, that means inversion, DC to AC. Because naturally we have AC supply, that is called converter. AC to DC means converter. If you are converting opposite, that is called inverter. Okay. But every time what I do, output side, I have to change the speed, change the voltage. Speed means that is proportional to frequency. So same frequency, but voltage is changing here. At different frequency, voltage also changing. That is called cycloconverter. Or for DC motor, I have battery. I am going to run a DC motor. So that is called DC to DC converter. So these are the basic classification of power electronics circuits. Then what are the features of power electronics? Problem is harmonics and EMI at load and source side. It produces a lot of harmonics. The electricity supply should be sinusoidal, but the power converter make it into rectangular shape. If you do the Fourier analysis, then you will find all the harmonics in different frequencies. Okay. This is only a discrete time system. Analyzing is very difficult then. To do the analysis power converters, you have to, your equations will be very complicated. To analyze, you cannot analyze, you need some software to analyze the power converter, their stability, all the things, filter design, everything. Complexity in analysis, modeling, all this. Fast advancing technology last 3 decades. If you see last 3 years, because of power electronics, there are many advancements. So when DSP processor came and this power converter came, you find everything in the industry or society. Many lift, your vehicles, LED, all this. So that is because of power electronics. And these are the field where there is fast growth because of power electronics. These are the fields you can see. And there is expansion globally because of power electronics. But why it is very important? So suppose I want to control a motor without power converter. So what I have to do? I won't use any power converter. I have to control this fan. So I have to take a old regulator, you might have seen that, step 1, step 2 like that, and some smoke will be coming from the top. So you are burning the electricity in terms of heat, that extra energy. So that is going waste. But nowadays you see the small regulator. There is a inside small semiconductor circuit which is taking care of this. You are not wasting any energy. 100% energy is utilized in the fan. So that is the advancement in power electronics. So apparatus at low cost, small size, high reliability. So the regulator size is very small. Just in your remote control, you are able to switch on and switch off the power converter inside your smartphone or smart TV. Okay, just you put a ray on that light activated SCR, switch will be on. So there is no waste of energy. Fast growth, that globally, environmental and safety problems, bypass all these things. Power converter never dissipate any carbon dioxide or any emission from the power converter, just it control the voltage and current. So if you are using renewable energy, all this, without power electronics, it is not possible. If you are going for solar, that is DC, but your requirement is AC. If you are going for fuel cell, that is also DC, you have to convert it into AC. If something is DC already, okay, but I need a control DC. For control DC, again, you need power electronics. So that is why power electronics is very important. So these are the applications for power electronics. Everywhere we are using power electronics. So from power system to chemical process to light, heat, light, all this electronics, welding, everywhere we are using power electronics. So in present society, without power electronics, you cannot survive. That means we need more number of power electronics engineer. But in our curriculum, I have seen that. In my state also, we are referring VTU curriculum. But we never give importance on power electronics, special machines, all this. We don't have. Very little we study on that. We don't have any advanced courses on power electronics. We don't have any elective subjects on power electronics. We don't have special machines. Special machines in power electronics application. But we don't have any curriculum. Whatever curriculum was there in 30 years before, also same curriculum we are studying. So that is the problem from the university side. So we never update. So these are some more scopes and applications. You can see everywhere you are using power electronics. So any field you work, now the industry need only power electronics engineers. And those are good in control. Like they also should know also soft computing, like your AI ML, your genetic algorithm, fuzzy logic, neural network, optimization technique, that is also applied in power electronics. 100 of paper every day published in this field. So again, if you want to be a good engineer in power electronics, you should have knowledge on these subjects. You should know power system, machines, converters, power devices, computer-aided design, okay? Then analog digital electronics, microcontroller, DSP, all this, then control theory. Because without this knowledge, simply if you know only power some converter, it convert AC to DC, DC to AC, that won't work. So you also implement all these things in power electronics. You should have knowledge on this subject. If you know the machine behavior, then accordingly you can design the converter and control. If it is 3-phase induction motor, my converter is different. If it is BLDC motor, my converter and control mechanism is different. So everything is interlinked. So this is changed. If this is changing, this is also changing. This is also changing. If this is also changing, whether I will go for IGBT MOSFET or thyristors or IGCT or any other type of device. Okay. So you should have the knowledge of all this. So now these things, you can see the 4th generation of devices, power semiconductor devices from the beginning. 1958 to 75 we had this. Then 85 during our graduation period, these things we have studied. So this ASIC thing came over there. Then now IGBT, then intelligent power modules, DSP. Once this came in 1995 onwards, then we have many electronics, Samsung, so many company launched. TV, refrigerator, everywhere we will find only electronics, power electronics from 95 onwards. Then all these advanced controls like DTC, vector control, all these things came during 1995. Then now we are here. We need these engineers. This is already developed. Now we need these engineers. AI will take care of everything. Okay, your algorithm will be also programmed by AI. DTC program is already available in the somewhere. So AI will capture that and will put in your system. And he will collect lot of data throughout the year and he will dump in your DSP processor that this many glitches or this many problems happened in this lift for last 2-3 years. So from that data, I will know that what type of fault might have occurred in the machines or power converters. So from that data, I can rectify, and for next, while developing the algorithm, I can incorporate that. which is beyond the human being knowledge. Okay, when it has been reached to the highest torque or highest speed, braking, all this, so data will be captured by AI. So these are the books, okay, and these are the publications for power electronics. This many conferences happen throughout the world every year on power electronics. And this is also some other conferences, and these are the company they are working on power electronics. Okay, so many of my students, they work in this company, Rockwell, Samsung, Siemens, okay, so ABB. So while working in VIT, many of my students are there and they have shared their PPT whenever they go for presentation for a lift or any micro oven or refrigerator, no, they share their PPT, sir, I am working in this field and we are doing this work. But they have so many advancement, I have seen that. So then once you know knowledge of power electronics you are having, after that the next term is drives. Drives means a system employed for motion control. Anything you are designing, there is a motion control. Lift, there is a motion control. Micro oven, motion control. Refrigerator, compressor, motion control. Air conditioner, motion control. Electric vehicle, motion control. So that motion you have to control through a machine and power converter. So that is called drive. Okay. So these are the advantages of drives. As I said, suppose there is no power electronics, I want to control a motor. So what I have to do? I have to generate electricity, so I need a generator. Generator will generate DC, that DC again I have to convert it into AC. Or suppose you have AC generator, you are generating AC, but you need a prime mover for that to generate AC. So that prime mover will be another motor. Now you need a motor, you need a generator, then after that generator output will be connected to another motor. That means to control a motor, single motor, you need 3 machines. But if you have power converter, just you connect that power converter to the supply, power converter will control output power and that power will be given to the motor. That means a single motor you can achieve that. So when there was no power electronics, you are using 3 machines to control a motor. So now the cost you just imagine, space you imagine, okay, we cannot keep in the ship or you cannot keep in the space applications, you cannot keep in the industry, so it occupies a lot of space. But power converter is small box, okay, like your inverter in your home. So that will replace other 2 machines. So that is the advantage. There are like this many advantages he has given over here. But what is the disadvantage with electric drive? Disadvantage is you need a source every time. From where you will get that source? If it is diesel or petrol, I can carry that. But if it is power electronics will not run by your diesel or petrol. So you need a electric supply. So from where you will get that electric supply? So that is the disadvantage. So for that, what you can do? You can carry a solar panel, you can carry a wind generator, you can carry a battery bank. That is the solution for that. If you are going to a hill station where there is no power supply, if you are inside the sea, there is no power supply, but sunlight will be there, wind will be there. So that can be used over there. You can charge the battery. And another problem is magnetic saturation and cooling problem, because it produces a lot of heat. Switches produce a lot of heat, and the output current has a lot of spikes, harmonics, so that will make heat the motor. So that is another disadvantage of drives. So now power electronics is that drives. Then let's go to electric vehicle. So what are the advantage, benefit of electric vehicle? So there is a battery pack, you can charge and run, and you can use for all these things, mobile energy storage, then for transportations, cars might actually create more value, their owners and utilities when they are sitting still. So these are the advantages. You are the ownership of that. No need to depend on others. No need to depend on Indian Oil or Bharat Petroleum. So those two companies are in your car itself. No need to make a long queue. You can charge in your home. Okay. You can spare battery also you can keep. Now swapping of battery also, government is planning to make that. Another battery you can swap to your car. If you have two car, another battery you can replace to that. So these are the advantages of electric vehicle. So it is also energy storage device. If there is a power cut in your home, I can connect my electric vehicle to my utility. So that will also energize my home, electrify my home. So it is energy storage. Electric vehicle is like energy storage device which will give energy to my home also whenever there is a power cut. So like this there are many advantages. So that is vehicle to grid, grid to vehicle. So I am going to connect a vehicle to my grid and collect money from the electricity board. Suppose I am not running my vehicle, so it's in my home. I will sell my charging whatever I have charged, and during daytime I can recharge again from solar panel. Again next day I can sell. Okay, so that is also another research topic: vehicle to grid, grid to vehicle. Okay, but that is not very easy. Again, these power converter problems. AC to DC, DC to AC, same frequency you have to maintain, harmonic elimination, lot of things. Okay. So now this is the slides I have taken from my class, from my smart board class. Okay. So here it is a DC converting into AC. So the input DC is this. Okay. So in the output side here I am getting something like the alternating current, something like this. But it should be sinusoidal, something like this. But it is a rectangular waveform because the input is DC. So this part I am cutting and placing here with these two switches. So red one, it is going like this. And this much part I am getting here. So current is going like this. So from top to down. Now these two switch when I am making on S3 and S4, it is going like this green one. Coming here, then here, then up, current is up. In this opposite direction. So this pulse will be like this. Green one and completing the path. So positive half cycle, negative half cycle. That is called alternating current. So this alternating current should be sinusoidal, but power converter is making it square wave. So this square wave I have to analyze because I need 50 Hz, but it has many Hz. If you do the Fourier analysis, Fourier series analysis, or in MATLAB we have FFT analysis, fast Fourier transform. Okay, it will give one graph something like this. It will tell that at 50 Hz voltage is this much, at 150 Hz voltage is this, at 250 Hz this voltage is this. Okay, but I need this voltage only. I need voltage only at 50 Hz. That means this rectangular waveform I have to make into sinusoidal waveform so that I will get this voltage at 50 Hz frequency. So now Fourier series means what? Fourier series means we have a fundamental one, this red one, plus third harmonic, fifth harmonic, seventh harmonic, all this. If we'll add, if we'll analyze, it is something like this. So this is the waveform. This waveform is nothing but this formula. So that is called total harmonic distortion. Whether it is 10%, 20%, 15%, but the standard is, IEEE standard is, this TST percentage should be within 5%. There will be harmonics, but you have to maintain within 5%. If you are not maintaining within 5%, then you cannot use your converter for any applications. Okay, this is the international standard. So whatever inverter you are designing, the total harmonic distortion should be within 5%, which is very difficult. Okay. So now, next what I did, Now, little, if you understand these small circuits, then complicated circuits can be analyzed easily. So whenever we teach our graduate student, so if we make all colorful, all these things, different modes, they understand better. Whenever you will give a complicated circuit, they can easily analyze and simulate in MATLAB. Okay. So here now, previously I had this converter like this, 4 switches, 1 source. Then I am taking another converter. Load is connected like this. So this to this point is shorted. If I am doing like this and I am operating the switches something like this, this is mode 1, mode 2, 3, 4, 5. This is mode 1, 2, 3, 4, 5. So I am getting a waveform something like this. That means I am getting a waveform something like this. Previously it was a rectangular waveform. Now it is stepped waveform, which is very close to sinusoidal. Now what I did here, another bridge I took like this and connected here with load. So for same power, if it is 5 kilowatt, now this rating of the switch will be divided by 2. The switch cost will reduce. Switch cost will reduce and the topology will be different. So, but in the output, the total harmonic distortion will be reduced. Now, in this, if I am doing MATLAB simulation giving to my student, yes.
What are the alternates to generate the gate pulses? And what is the frequency we can keep to generate the gate pulses for the switch or from switches?
That you see, to make it on and off, there are different type of switching techniques are there. Okay. If it is a thyristor and IGBT or transistors, what is the difference? In thyristor, you have to find the time at what time you are going to fire the thyristor. Either 2 seconds or 2 milliseconds or 3 milliseconds like that. Once you fire the thyristor will be on forever. Okay? But you cannot switch up that. Only when negative half cycle will come, automatically it will be naturally commutated. But in IGBT, if you are giving the signal to your control signal, that device will on, and if you are removing that signal, device will be automatically off. Now, so one cycle is how much? 50 Hertz. 1 by 50 is equal to 20 milliseconds. So in 20 milliseconds, you are doing the control. If you want, I can tell in the whiteboard. You are able to understand?
50 Hertz is not enough to generate like you are generating the SPWM. In the SPWM, you have to compare.
No, that sinusoidal pulse with the modulation, that is different. Okay. Can you, okay. And you are getting a pulse something like this. Okay. This pulse is giving to your switch. So now this pulse, you see, this pulse you compare with your sinusoidal waveform. If we take the area, this mid area is more. Here also, this voltage is more here. Side pulse is less. Here side voltage also less. If you do the Fourier analysis of this and this, it will be very close to this sinusoidal waveform. Now we are telling this time. If I change the frequency, now my frequency is very low, then pulse width will be very high over here. So now we have two control. I need 50 Hertz, so this is my reference. That I will not change. That is given here. But this frequency I can change. So based on this frequency, the output voltage will change. But what is the best frequency so that you will get less than 5% THT. So as I said, finding it may be 1000 kilohertz, it may be 1001 kilohertz, it may be 1002 kilohertz. Human being cannot do that. So you need help of neural network or fuzzy logic or your optimization techniques that will do that work. So present days people, they have published a lot of paper in that area. Okay. So now this signal is given to your IGBT or MOSFET, it will work on like that. So nowadays thyristors are not used mostly because this IGCT, IGBT, all these are very advanced. Switching losses are very less. Okay, it's clear? So this switch is decided by your DSP, microcontroller, all these things. Nowadays, dedicated DSP for a drive. So this frequency generator, these sinusoidals or blocks are already there. Okay. Just you have to reprogram that one. Okay. So this is called multi-level inverter. That means you are getting many levels over here. So total harmonic distortion is only 12.36. Now if I am using a filter over here, capacitor, then the capacitor size will be very less. Cost will be very less. So that means overall cost of the inverter decreased now. Because many switches, but the switches rating has been half. Okay. So by this way, this is by changing the topology of the converter, you are able to reduce the harmonic in the output side. I am changing the topology. But what I explained here I am using PWM technique, pulse width modulation technique. There are different type of pulse width modulation, staircase, sinusoidal, many pulse width techniques are there. So by this technique also, I can reduce the output harmonics. No need of this many switches. So previously I had only 4 switches. After these 4 switches, instead of assigning only this one on, this 2 on for how much time? This is 20 millisecond. This 2 on is for 10 millisecond. And this 2 on for another 10 millisecond. Okay. So, but what is happening? I am getting harmonic in the output side. So instead of that, what I can do? I can go for PWM technique, pulse width modulation technique. So these signals I will provide to these switches. So my output voltage will be something like this. Now this 2 switches on for this much time. So output also will get this much of time, then this time, then this time. So whatever signal you are giving to the switch, that much voltage will be passed to the output side. Okay. So that Fourier analysis I will do. Nowadays this FFT analysis, all these facilities are available in all software. Easily we can do that. So whenever you are going for hardware implementation, what do you do? Same frequency utilize there. Okay, you can go for a microprocessor, microcontroller, DSP, FPGA, ASIC, all these boards are available nowadays. You can program it accordingly. So now another thing here. There I used 4 plus 4, 8 devices. But how many levels I am getting here? Same 1, 2, 3, 4, 5. There also I was getting 1, 2, 3, 4, 5 levels. But here how many switches I am using? 1, 2, 3, 4, 5 switches and many diodes. Diode cost is low. But what I did here, there I changed the topology. Again I am changing the topology. Same 5 level I am getting here, but less number of switches. That is called reduced switch power converters. Reduced switch power converter. Less number of switches, but same output. Okay. So then what will happen? 8 switches I was buying there. Now only 5 switches I will buy here. So now if you want to analyze these things, switch on S1, S4, S1 and S4 you will get this voltage. Switch on this, you will get this voltage. Your circuit theory thinks these 2 voltages are input, 2 voltages are there. So you will get a voltage something like this. So now what I am doing? I am doing some work with the power converters. I am reducing the switch, making many level, okay, or I am using some PWM technique or some control mechanism so that the output voltage will be more sinusoidal. So that is the challenge in power electronics. Who is going to do the best one? Because getting 5% is very difficult. So who is going to get very close to that? Then if you are going very close to 5%, my input power factor is affecting. So input power factor also you have to maintain, because input is AC. Power factor is very important. Now the input, if input is output is straight line, input current will be straight line that is connected to your bus bar. So you are injecting harmonics to the bus bar also. So these are the problems. So now everything is interlinked. Your output voltage is linked with the input voltage. Okay. If you are making more sinusoidal over here, current is constant. Load side current is always constant. The current harmonic will be injected to the bus bar. So these are the problems. Then I started with my MTech students, some 7 level, 9 level. So now there I get different level, no? Here these are the levels. Okay? So how many level you can make? Suppose I will make 100 level, but 100 level means my topology will be very complicated. So many H-bridge you have to connect together. Then it need more space, complex. If there is any short circuit, there will be a problem. So we cannot go more than this. So in the research paper, they have gone till 7, 9, 11 level like that. Okay. So all this work I give to my student. Then he simulated. Now he's getting in MATLAB, he's getting this output, and he's telling that which switch is on at what time, which voltage will get in the output side. Okay. So these things they publish in the conference papers. Okay. So for different level, now these are the different type of multi-level inverter. Natural point clamped multi-level inverter. So this is many type of inverter. So now researcher what they did, which type of inverter is suit to your work. You can choose. If you are choosing, then you have to, suppose you are choosing this, then how many main switches are required, how many diodes are required, how many clamping diodes are required, how many DC buses are required. So all these things, they made a generalized formula. After doing lot of research, so they understood that these are the generalized formula where n is the number of levels. So now if you are going for 7 level, this many things you have to buy. This many diodes, all these things you have to buy. If you are going 9 level, these are the different modes. Okay, this is the output. These are the devices. Okay. So now these are the devices. After that, different type of topology. Suppose you are connecting to the grid, they made different type of classifications. With DC to DC converter, without a DC to DC converter, with isolation, without isolation. So like this, many configurations they made. Okay. Now the power range they classify. So they made a tabulation of that. Okay. Those are rigorously working on power electronics. They made different classifications. So because everything is based on your costs, your project costs. Your project money should support to buy all these things. Or your vendor will tell that in my electric vehicle total cost should be within 20,000 rupees. You tell me which one will be the best. And life should be more. Like Indian Railway will tell that if you are taking my project, whatever you are giving me, it should run for 25 years without any mistake. That is a railway project. So like that they will ask, your customer will ask like that. So as an engineer, you should make a comparison of all this. With isolation, without the isolation, here DC to DC, again DC to AC, with low frequency, here high frequency means switching frequency should be high, then switch cost will increase. So there are many criteria you have to check. Then another classification, if you are using solar panels, maximum power point tracking is a technique to maximize the output power. So these are different techniques. So yes, they have made a comparison of all these techniques. Which one is good, which one is efficiency is high, medium, all these things. Okay. So these are the different connections you can give input side, whether you are going to use a maximum power point tracking or output side. Here input side, they have made it, but signals they have taken from input side. Here also input side, both are connected parallel like this. Here you can say they have taken from this to this. Okay. And the output connection is something like this. So output connection is different here. Here again another configurations. They are taking output, here input signals. Here input signals, then some more PWM modulator, other things they are incorporating on that for better control. So like that there are different configurations. So these are the different topology. Okay. So why I am showing this, all these blocks, you'll get some knowledge that this many type of power converters are there, and this many type of topology are there. This many type of control techniques are available already in the literature. You will get some idea on that. Then in multi-level inverter, you have different types. Okay. So this is one type of multi-level inverter that is divided as voltage source and current source. Then this many types are there. People, they have already worked in these types. So you can choose any type of this or any type of this and work on that. So these are the different topology you can see over here. Okay. So it is not very difficult to understand how this DC is converted into AC. It's very simple. Okay. Just you download that paper, you go through any textbook. It's from the basic, how I explained that H bridge, similar manner. There will be different mode. Mode 1, these switches are on. If this switch is on, current will flow through these switches and to the load and close the path. That's all. So now all this multi-level inverter, how many switches you need? Because your cost depending on these switches. So now these are the topology. These are the different topology. That means you take switch, connect here and there, finally you get your required output. Once topology is ready, after that you have to control the output voltage. So these are the different control technique. Sinusoidal PWM control technique. In BTech level we study that. Then advanced power converter, whenever MTech we study, hysteresis, selecting harmonic elimination, space vector PWM technique you study. Then after that, whenever you go for your project work, other things, they'll tell, oh, you already know this PWM technique, you can apply all these techniques. Okay, so there are different techniques to control the power converters. Then, so whatever technique I said, whatever sinusoidal I said with carrier signals and your reference signals, now you see how complicated it is. Okay. So different type of pulse width modulations, technique with phase disposition and your phase shift, all this. Then this PWM technique, what are the problems? You are using PWM technique to reduce the harmonics, but further we will find these problems. Because you are operating your switch in kilohertz and megahertz. This signal is in kilohertz or megahertz. Because I want specific control. My electric vehicle should stop at 10 feet. So the pulse width modulation should be very accurate. So because of now you have the switch you are going to make and on and off in kilohertz and megahertz. But your switch will not withstand. What it will do? It will produce some spike. Like your water tap you open, water pressure, similar way the electric pressure will produce some spike. So, and it produce heat. If there is, your voltage is 220 volt, but it is producing a spike of 2000 volts. So it will produce a lot of heat. There will be short circuit, wind will burn out. Okay. Then electromagnetic interference. I have seen while studying graduate, if someone is changing the regulator, no, in my radio I will get one noise. That is electromagnetic interference. But here only once you are changing, but here it is operating in megahertz, kilohertz. So if your any radar kind of things or communication is there now, that will get disrupted. So these are the problem again in power electronics, not only harmonics. These are the problems you have to overcome these problems. Now to overcome these problems, people already they have implemented all these techniques. Okay, but I worked in only this PQ, active and reactive direct power control. Okay, so my guide, he suggested me this is the field, is a good field, and you can work on that. So I started working on this, and I asked my student to work on that. So for that technique, direct power control, we have, these are the different blocks. I have to calculate the active power, reactive power, okay, hysteresis controller, all these things. So I have taken information for my lookup table. You see this many informations from IA, IB, IC, voltage sensors, current sensors, compared finding error given to lookup table. Then in inverter we have a DC link data. That DC link also I am putting there. All these informations are this formula. This formula you have to model in MATLAB. Okay. Once you are modeling all these things, finally you know that your vector is rotating in a machine. Okay. VA, VB, VC is a resultant vector. That resultant vector is rotating inside that. Now if I am able to control this vector, the less black vector I will control. If I am vector size is less, angle is less, then accordingly my speed will change, torque will change in the machine. So flux I am decreasing, angle I am decreasing. So I am getting this vector, red one. So now whenever I am switching on and switching off, my inverter has 6 switches, T1 to T6. Okay, 1, 3, 5, 2, 4, 6. If 1 is on, then 6 should be off. In one leg, both the switches will not on. That means I have only 3 switches option. 3 switches, 1, 3, 5 switch status if I know, then you put one not get. So not get output will be 0. If upper one is 1, that signal, then next switch I will make through a not get, so it will be 0. So it won't be short circuited. That means I need only information of T1, T3, T5, odd number of switches. So let's T1 is 1, T3 is 0, T5 is 1. That means 1, 0, 1. So that means I have how many states? T1, 2, 3, 4, 5, 6. So every time I am playing with 6 vectors. But 2 power 3 means 8. 8 states. The other 2 states are 0, 0, 0, 0, 0, 1, 1, 1. That means that is here in this point. 1, 0, 1, 1. So I am putting in the switch, I am getting V5. 6 means 1, 2, 4. 4, 1, 2, 1. So 1, 1, 0. If 1, 1, 0, 1 means on, 0 means off. 1, 1, 0 means T6 I am giving. Now my vector increased. Vector, this is increased. Okay. So this vector plus this vector, I will get add this one. So I will get this the resultant vector. Now this blue color vector plus V2 will add, I will get a black one. So now by changing that switch status, I am getting a bigger vector, I am getting a smaller vector. That means the flux inside the machine I am able to control. Okay. This vector, blue vector is nothing but your sinusoidal. That is sinusoidal flux. That flux magnitude I am changing every time. Okay. So now next what I will do, I will increase. I mean increase means the red one is now top. B2, 0, 1, 0. 1, 2, 4 digital, 0, 1, 0. 0, 1, 0 means 2. So 0, 1, 0 if I am giving, then I am getting a big vector. That means flux increased. It will take more load and we can run at more speed. Okay. So this status I am able to keep in a lookup table. Now everything is programmed. I know this switch, if it is 1, 0, 1, my vector is this. If it is 0, 0, 1, vector is this. So I am making a lookup table. So from the lookup table, if I am making the drives, finally the inside flux will be changing something like this. Okay. So whenever you are running the electric vehicle, either you have to stop, or if you are running, you have to run in less speed or more speed. Okay. Either you can go for 80 or 120 or 90. So that I have to change. So who will change that? Inverter will change. Inverter is giving energy to the motor. So I am controlling my inverter here. By controlling the DPC control, direct power control is controlling that. So direct power control is an algorithm. That algorithm I have decided by analyzing. My mathematical formula I have analyzed. If I am giving 1, 0, 1, my speed is this, torque is this. Okay. So these things has been programmed and finally you will get this. Then some research what they did, they said okay, in DPC we will make some changes. Okay. So then deadbeat, model predictive control, like this many people they worked on DPC. In that same control mechanism, they add some more features. They made a model. That model will be compared with your real model. If there is an error, according to error, then decision will be taken. Okay. So like this you can complicate it for your PhD work or some research project like that. So now for different control techniques, different block diagrams. Each block diagram you have to understand. Suppose these things I am going to implement in my electric vehicle, okay, definitely it will be very costly affair. But it will be costly for only one time. If Ola is implementing this or ABB is implementing this, you will implement only one time, but you will make million of vehicles. Same control technique will work for that. So like a good doctor, no, everyone will queue on to that doctor only. So your electric vehicle is working fine, then everyone will buy that. Okay. So these are the different block. Then you see that whatever TSD I was telling, for different control technique, what is the TSD? All are less than 5%. Only this fellow is 7.5%. But if you see the DC link voltage, other things, that may be different. Okay. Computation time, here it is more, but this is less. This is more. This is somewhat manageable. So you can do the analysis for different control techniques. So now these control techniques are already published. So you have to do what? You have the same things you have to implement in MATLAB. Then my computer science students are good in AI or neural network, fuzzy logic, genetic algorithm, or particle swan or your any other algorithm. So try to incorporate here, because as the chief guest was telling, data. If you have data, you are the owner. So now you collect more data on that, train your networks and make a controller which will reduce this, it will reduce also this. Because in gigahertz, kilohertz, no, it takes a lot of time. But whatever nowadays AI techniques has come, no, it takes very less time. Very clever codes they have written so that it will take very less time your processor. So now again, some comparison of all these techniques. And if it is grid connected, also you have to make all these solar panels. Grid things will not give importance. So these are the standards. Whenever you develop a project, you have to, there are two types of European countries, they refer these standards, IEC standard, and these Americans, they go for IEEE standards, and these are some other standards. Like maximum current total harmonic distortion, it should be 5%. That is valid for both. Harmonic current per order, different order, third harmonic to 10th. If it is 10 kilowatt system, this 30 kilowatt system, they have standardized this. And this DC current injections, okay? So this you have to maintain. If you are not maintaining, you will tell them, no, my total harmonic distortion is 1%. They say, no, it's not possible at all. That means you have violated the standards. So nowadays, some people, some industry, they said power converter is like a universal tool for everyone. And you know that every time you go for 6 switches for your 3-phase and 4 switches for your single phase, and protection required, gate driver required, auxiliary power supply required, DSP ports are required, integrated heat sinks are there. So they make a module of that. So no need to buy these switches, give connection, all these things. So directly you can go for IPEM. Because nowadays topology, everything has been researched many times, but they found that there is no meaning of changing the topology every time, but you can change the control. Don't play with the hardware, play with software. Okay, software has no cost. Just code is such a way that same 6 switches will give a better output. So algorithm has to be changed. Your coding has to be changed in such a way that, because that never cost any hardware. Just you have to simulate, run and give to this processor. So that does not cost anything. Suppose you are changing the topology, instead of these 6 switches to 3 switches or 5 switches, all this, that cost will matter. But again, there may be a malfunction of that. So they standardized that IREL, International Renewable Energy, USA, they have made some standard IPM models. So you can go for this model directly and change your algorithm. So these are the different modules for, this is for PV fuel cells, this is for wind turbines, this is for battery. So they have made some topology. That is standard topology you can use for this. Okay, people, they did a lot of research on topology, changing other things, but finally they found that that is useless. Okay, suppose there is a malfunction. No, previously 3 legs were there, but you are making multi legs. If multi legs means sub switch also got damaged, that closed loop will not form. So don't go for topology changes, just go for algorithm how to change. So these are the control functions, okay, that modules, okay. So this is for a distributed energy generation, different IPM module 2. And this is the first project we have done, that my DST project, where this many, we have designed everything on our own. We didn't buy any module. We have bought these solar panels connected in string, something like this. This many DC converter we have made, and we have designed our own inverter, multi-level inverter, 5-level multi-level inverter, then isolation connected to the grid. That is implemented in VIT University, Vellore, rooftop. So that is till that it is working fine. 10 kilowatt solar power plant. So the nobility in this is this connection. Because in multi-level inverter, what you understood, input DCs are more, number of DC inputs are more, not a single DC, multiple DC input is required. So multiple DC input. Then whatever DC you are getting, you can boost that voltage by connecting one DC to DC boost converter. Then that is given to your inverter. In inverter control, direct power control we have used, which is very efficient controller. Then all the ratings, other things are given here. So this is our research lab. Okay, so this is a grid connected to this, and all equipment we have invested all the 45 lakhs, and VAT overhead charge also they have said you can use that also for your work. And these are the, actually this work already to be published. These things, don't mind, these things will not be shared with you. This is already communicated, many papers already published, and this work also we have communicated to many journals with my PhD students. Okay, so the data are just for your reference, that this many work you have to do, accurate calculation you have to do, all this filter, boost capacitor, all these things you have to buy for your design. Then these are the different techniques. That is ant colony optimization technique. Okay, this is ant lion optimization, this one, red one. So like this 3 different techniques has been used and compared which technique in different radiation, which one is best. So this is perturband observes, this is incremental conductance, this is ant lion optimization. So ant lion optimization technique are giving better result. If you take throughout the day time, okay, so it is giving better result. That means I should use that technique. So this is another comparison. So these are the different, you can see the voltage sensors, current sensors, okay, and IGBT modules. So you have used DSpace. DSpace is very much compatible with your MATLAB. So whatever simulation you have done, you want to realize in hardware, DSpace will help for that. Directly you can link with that. So your controller, your simulating and your programming part will be in MATLAB, hardware part will be separate. So DSpace will interface between these two. So these are the different sensors. These are DSpace different ports, okay, and the power analyzer. These are the different outputs. So no need to go in details what you are getting over here. So this is different control technique outputs, okay. What you are getting here, no, these waveforms, because it is required whenever you are writing a paper, no, these waveforms with this data is required very much. If you don't have these things, no, they'll tell that you have copied and pasted from somewhere. So now this figure, suppose someone has copied and pasted somewhere, easily I can catch, because once he is taking this figure, no, I have already published in this, that paper will be automatically linked with your Scopus or Google Scholar. Then I have already, my email ID is registered. They'll tell that your paper has been referred already by this author. When I'll download this paper, if I'll find this figure over there. So I'll give a complaint that it has been copied from my paper without my knowledge. So they will blacklist that author. So many authors are got blacklisted like that. So anything if you have not done that, don't publish, because your name will be blacklisted for 5 years. You cannot complete your research, you cannot complete your PhD. So that is the problem. Otherwise, you do some simulation kind of things or mathematical analysis or some review kind of things, that way you can publish the paper. But don't copy at all from anywhere else without anyone's permission. Suppose with permission you are taking, the author will tell that you have to refer my paper in your reference. In reference, if you are referring my paper, then my H index will improve. So journal impact factor will improve. So finally what will happen nowadays, they have given the 2% scientist, there are some researchers' names are the 2% scientist. So by this way they calculate all the things. How many of your papers are referred by others. So if someone will send a mail that I am writing a paper, I want to refer this figure or this, if I allow and will ask to put my paper as a reference, then I am also getting benefit, the author also getting benefited. So that way research only happen. So now these are the different control technique and compared all the technique, sensing parameter, tracking factor, all these things. So this is 5-level inverter, switching table, topology, output waveforms. Okay. Then total harmonic distortion is getting 4.84, which is very good. That is current, that was voltage, this is current. Current also is getting 4.94. So this is the DPC control output waveforms. Okay. This current, voltage, voltage per unit, power, power per unit. Then next another one is getting 2.8. So this is the complete setup of the laboratory. This is your firing circuit design. Whatever PWM technique you are generating, no? So you have to sit, give this much connections, connected to D space. I was telling interfacing, no? Now here it is convert your digital things to analog things. You are giving digital MATLAB, digital 101, all these things output to 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 because it is some 5 level like that you are making this many switches. So that many triggering circuits are there. So these are the different outputs. Then this the paper we have. This journal impact factor is now more than 15. Renewable and sustainable energy review. So different grid connected PV system we have done a technological and status review and published in RSER. So then another project we have done in reduced device count by using less number of switches. Another project we have done. So I'll quickly go through. No need to go in details all this. So same thing, whatever theory I said, same points you have incorporated here. Number of devices, all these things. So these are the output for 7-level device conducting all these things. Then different PWM technique has applied with the same topology, different type of technique has been applied. So now these are the carrier signals and your reference signals compared together to generate the PWM that is given, and finally you will get the outputs. Here he is getting 11.82, 11.82. I think the one is for 5 level, one is for 7 level. So finally, after incorporating that advanced technique, he is getting 4.6 TSD. So that is the, again in the same lab, same project I have completed 7 PhDs. Same project setup, I completed 7 PhDs. Because my resources is a licensed version of the MATLAB, DSpace, I have 6 IGBTs and all the sensors, voltage sensor, current sensor, measuring your instruments. So with that, you have to change only the topology, you have to change only the control technique algorithms. That's all. But your focus is on power electronics. So these are the hardware things. So this is the complete project of that student. So PQ box output is very much useful for research papers. All this figure you have to give, it will give the figure direct where just you have to paste in your paper. That means the reviewer will know that you have done the real hardware work.
What is the cost for this?
It's vary from minimum 5 lakhs. Okay, the PQ box is minimum 5 lakhs and again advanced version also available, and many company are there, the manufacturer of this. Then next another project, what she has done, she has used model predictive control. Okay, so in model predictive control, modeling. That means whatever you do a mathematical model of that. Compare with your real-time system. Then check the error. From the error, you should understand whether your control is good or not. So now, in model predict control, you can see that, as I said, 6 vectors. You have the 6 vector. Vector 1, 2, 3, 4, 5, 6. Your inverter is operating in different points. In that 6 hexagon, it's operating million of points. But from the million of points, you understood that this much point is only used for my drive. If it is a lift or electric vehicle, only this much of point I am using, not more than that. But sometimes if I am running my electric vehicle 80 km per hour or 81 km per hour, no difference. Okay, so next what you understood? From that, again you understood that only this much point, not that much of point. Previous one, so many points. As I said, 1, 0, 1, 0, 1, 0, all these things, you know. So he understood that if I'll check with this many points and output performance, and this many point output performance almost same. So why should I go for remaining points? Why should I go these points? Better omit that point. Okay, so I will not operate my inverter in those points. If I am operating this point, instead of going this point, I will go for this. 80 and 81, there is no difference. So by this way, all this mathematical formula, you see, as I said, no glitches, you are getting no glitches over here, spikes, that is very dangerous. Okay, so whatever we have done for research, not for real-time applications. Whenever I am going for real-time application, now I am getting some spike over here. Okay, this is more than this peak voltage also. So I have to use some filters to nullify that. But that is, I am not using any filter here because I am doing for research. In research, my control algorithm, how it is working. That is my focus. My focus is not to filter the output voltage because this much spike is only for 0.002 millisecond. After that, again it is coming back to original. So a small capacitor will take care of that, or small LC circuit will take care of that. Okay. So these are the different outputs, and this the different blocks they have used. Because in research you need this type of performance, not pure sinusoidal. You see, from this is one cycle, one half cycle. But you see how it is changing, the voltage, how it is changing. Why it is changing? Because I want precision control. I want my control should be in microsecond, not even a millisecond. If I apply brake at 10 feet, my vehicle should stop there. That means if I stop somewhere here, if I apply somewhere here, my vehicle will stop at this point. So this much millisecond, so voltage, whatever I am energizing my machine, no, that much it should take care. My controller should take care of that. So these are the harmonic analysis and other things. Output wave. So this is different case study has taken with different loads, balanced load, unbalanced loads, okay? Because the windings are not always same. It may differ, inductance value may change sometime. So she's getting 9.70 in model predictive control. Then some other case she got 26.05. The next project, that is matrix converter. So your switches are connected like a matrix. Which switch will on at what time? And each switch is something like this. Two switches are inside, two diodes are there. It is connected something like this. That is nothing but this switch. So it is very complicated. So which one you have to on at which time so that the output voltage will be better. So matrix converters are very complex. So that is why very less people they have done research on that. But it is easy. You just buy this module, connect like a matrix, something like this. No topology, nothing. But your controller, you have to design. You are good in analyzing things. If I am switching on this, output voltage is this. But I want something else. So instead of switching on this, I'll switch on this. So I'll get a better output. So you can analyze that and develop your algorithm. So 8 point something is getting, okay. So it's not a good result. But it is a PhD thesis work because in matrix converter, very less people they have reached to this. So that model predictive control again in the same journal because I like this journal from the beginning. And because of this journal, my name has come in 2% scientist because many citations, impact factor is 15 plus something, okay. So I always prefer to publish in this journal. So she is my PhD student, and I also worked with this university, Naresuan University, Thailand. Yesterday also I signed a MOU with, now I am changed from BIT to another government college. So I approached the government, I want to sign a MOU with this university, so they agreed. So we'll sign it. We applied for a project, same that AI technique for this electric vehicle and all, that project also Thailand government they have approved. So that is more than 80 lakhs in our currency. So that way we can, so whenever you are going somewhere, you just make friends with these foreigners. Because if there is a foreign co-author, then your like ranking, other things, will go ahead. So presently we have this project. 2019 we have got and 23 we have completed. This project is around 13 lakhs. Okay, this is also grid connected PV West Smart Rural Homes. That is from National Project Implementation Unit. We have got this project. So that project is now going on in our present institute where I am working. That is a 5 kilowatt solar panel with a smart inverter. So that is prediction of solar energy, all these things you are working on that, and rural electrification on that field you are working. And that also we have published this June 2023 in Renewable Energy Focus, okay, in that journal. It is also a very good journal. So this is the paper we published in which year? Year is given? No, this is November 23 student at this one. This is actually, Ankit is my MS student in EIT University. He has written a review paper on, now in inverter what you do, different stages are there. So single stage, in single stage how many inverters are already published, he has done a comparative analysis, okay. That is also in the same journal, okay. So one type of converter, this one. And this is Saran Chaurisia. I sent him to school of this. This is Chile and this is Thailand. This is Naresuan University. For his BTech project, I sent him to Thailand for 2 months to work in their laboratory. And he came back after 2 months. Again, after 1 month, he went there to receive his best project award. Then he went to Sweden to do his MS. Now he is working in Denmark in an electric vehicle company. and his package is more than 80 lakhs. He just MS. So because of this, B.Tech student publishing in RACR journal. So that is very important. So, and the collaborative work, country Chile, Thailand, India, in one paper, 3 different countries. That means we are working globally. Climate change is because of globally, not locally. So we should work globally. Now these are the, presently they are using for AB application, these are the converter used. I have taken from the different research papers. These are the different power converters used, DC-DC converters used for electric vehicle. And if you do the analysis, power range, reliability, bidirectionally, because regeneration is important, bidirectional controllability, efficiency, then you can see that which one is good, which one is bad. Someone is bidirection, someone is good, but a bidirection, this one is not good, this blue one is not good. Okay, this yellow controllability is good, BC also controllability is good. Okay, so now in your electric vehicle, control is important, efficiency is important, power range is important, or reliability is important, or you want regeneration is very important. You have to choose which type of converter is suited to you. People, they have already done research and made a comparative study. So this is only for DC to DC converter. Then this is the one topology here, DC to DC converter. You can see how many switches they have used. But this has been, after doing the analysis, the researcher is recommending for EV vehicle, this configuration is better. Okay, this interleaved, multi-device interleaved DC-DC boost converter is better among all these converters. See, last one is telling this one is better. The next, inverter. We have 3 different type of inverter he has analyzed, and he has done the comparative analysis among all these parameters. Okay, and you can choose accordingly which one is good according to your application. Then onboard charging, offboard charging. So these are these two converter rectifiers are used practically present days for electric vehicle applications. So this is for charging. Then for charging here they have done the analysis with these parameters, these 5 parameters. Which one is good? Which one is good in bidirectional? Which one is good in efficiency? All these things. So you can see that controllability is not good, this blue one, but this one is good. But bidirectional, blue one is good, but yellow one is not good. So you can choose accordingly, because regenerative braking, battery charging also very, very important. So now this is the circuit for wireless power transfer. So that Saransh Chaurisia, he has published on wireless power transfer. He has done a review on wireless power transfer. Now also he is working in that wireless power transfer after his MS. Okay, so this is a simple circuit for wireless power transformer. So finally, we should think of this simplicity, efficiency, stability, and utilization of voltage source. Cost does not matter. People having a lot of money. Ola bike is more than 1 lakh. Activa is 70, 80,000. But people still favor Ola. And Ola every day they launch one version. Because they know that people have a lot of money. Okay. So accordingly they do the design and fulfill their requirement. So these are the different inverters. So finally, the future of our renewable energy, electric vehicle, all this is Internet of Energy, Internet of Service, Internet of Things. These 3 things we have to work on this field. Internet of Things we already know. Okay. Now Internet of Service, my Ola, now I am in this situation, my service center is somewhere, I should find in my smartphone itself that service I want from the Ola. Okay. Then Internet of Energy, how far is that charging station? Or Ola will tell that someone is selling from his home power I should detect that one. Like in my Google, I am putting how many HDFC banks are there nearby me, I am able to get easily. So how many charging stations are there, I should know in that instant. So this will give. So that facility should be also provided. So for that, what you need? This cloud computing, smart grid, all these things. That knowledge also is very much required. Now these are the energy sources. We are interested in what? We are interested in solar, thermal. Okay, photovoltaic is yellow one. You can see the yellow one is photovoltaic solar. So now we are here, somewhere here. 20, somewhere here, solar is this much. By 2030 will be this much. Okay, 2050 almost we are using solar. But where is our coal and nuclear? Coal is this black one. Okay, what is this blue one? Natural oil, gases, all this. So it is narrowed. Okay, so in future you are going to use only these things, this yellow color and orange color things. So now again, electric vehicles need to come of age by 2050. Electricity, this green one. Plug-in hybrid, this much. So, but all these things is going to gasoline, is going to vanish completely. So this is the from WWF. So you are going to work on these sources only. These sources. So these things will die out slowly. So energy integration, we have this type of things. Now presently we are going to get this. Smart grid, microgrids, okay. New communication and control models, electrification of transportation, integrating energy storage. So these are the field you are going to work. So by renewable energy, if you see energy demand, non-renewable and global. So you see by 2050, you are going to use final energy here, this one. Only renewable energy, other things will get vanished. Non-renewable will vanish completely. So this is my last slide, okay? Because there are war going on everywhere. I've seen that present war in Ukraine war was old, that new war now, Hamas and Israel. Okay, so what is the root cause of these wars? Nobody knows. Okay, whether Ukraine is telling that my mineral I have to sell to European country or Russian. Russian is telling that if you will sell your mineral to European, then I will attack. That means what? That mineral is nothing but your maybe cathode of your battery. Okay. So the hero of the environment and chairman of chief scientist, this Institute Times magazine, is telling this. In future you may face many wars because of climate change. So now the ministers are very much worried. They are telling electric vehicle for climate change, pollution, all these things. But in their head, in future you are going to face a war. So we have to be very careful for that. So how will sustain? So you have to work on that. So this is the book, the e-book you can download from internet, is freely available. Okay, so you can see renewable energy over here, and there is war in the front page of the book. So that is why we are not worried for energy or climate change, all this. We are worried for maybe World War III. So you have to either choose right or left. It's up to you. You have to go for petrol or you have to go for electric. So thank you very much for giving me this opportunity. Okay. And this is my email ID. Okay. And if you have any query, you can ask. Any suggestions?
So in the beginning, you mentioned that the battery prices are going to be reduced day by day. But I am using my electric vehicle from past 12 or 13 years.
Oh, very nice.
Day by day, the battery prices are going high on this. How the
But the statistics is saying here, battery price is going down. But it's depend quality of the battery.
but also the electric vehicle prices 2-3 years ago, what were the prices they have been changed? Now the companies are quoting greater prices now.
Price is one thing. It's depend upon the market. If my selling is good, then I'll increase the price to balance my budget. That is true or not?
Yes, sir. But I have purchased both the lead acid batteries and lithium-ion batteries.
I changed my car battery recently. I had AICTE battery. I paid more than 5,500 rupees that time. Now I purchased Amar Raj, 3,600 rupees.
Same age battery, sir.
Now performance is same. And I asked another friend, he said, you don't know that Amar Raj is better than AICTE. So now same battery, but cost is different. So cost will reduce when there is a competitor. Competitor then, because everyone want to earn money. Like your smartphone, no, you see, competition, one feature is they're adding, okay, million in one day, million of cell phone they will sell. So the cost is different. Cost we cannot tell, but if you see the cost, they will analyze only those are the doing analysis, not cost in India. Globally, how cost reduced, because
One thing, sir, if we compare the petrol vehicles prices with the electric vehicle prices are more. So if those prices,
you see electric vehicle means,
the people will go for electric vehicles more, then we can reduce these kind of conditions.
now they are telling you also can manufacture your electric vehicle. Government has allowed. In your home, if you are able to capable of manufacturing, you can manufacture. But what Ola is doing? Ola is doing business. So how will I attract people to buy my vehicle? Through advertisement, through some AI technique applying in my vehicle. It's not theft, just a fingerprint, it will get start on all these things. So that fingerprint switching on, cost is more than your other accessories in the electric vehicle. But whatever you will manufacture, there will be a DC motor, one battery, just one seat and like a cycle. That is also electric vehicle. This is also electric vehicle. Then how can you say that electric vehicle cost increased? Increased because of something else. And in the society, people are there because they are not able to manufacture, demand is more. So if the demand is more, what do you have to do? You have to increase the cost. Otherwise, everyone will buy. They cannot manufacture that much. So cost is different. The cost you can analyze only those are manufacturing, the scientists, those are making the anode, cathode, battery manufacturing, they will analyze the cost. When they are importing the mineral from China, previously it was this much rupees, but now it is less rupees. Why? There is pressure from the United Nations, you have to sell that mineral because climate change, you are not suffering, everyone is suffering in this globe. So that is a pressure for that. So electric vehicle means you have to think which category of electric vehicle. How many of you are electrical engineer? Can you raise your hand? Okay, very less. I think they might have understood power electronics. Others, they will be thinking that that is something different, not in that area. Ah.
It's not a very actual. I'm basically from industry background.
Yeah.
See, currently, if you see today, especially in India, the lot of failures, field failures happening. Most of it is from the controller, motor controller.
Yes.
And in also, if you look at, they are not repairable. Generally, they are replaced, and most of it is now coming from China. Because in India, there are hardly, I think there are nobody now today manufacturing this motor controllers. So it's replaced, and this is a big concern in the current EV industry in India. And the major problems which are coming is that one is the spike which you already understood. The spikes are one which still people are not understanding how the spikes are coming. So it is still maybe you have got a good understanding. I also try to see what you are doing, but in industry there is no much knowledge on these spikes which are coming. This is the first point, and the second point is there are some manufacturing issues which are coming up in these controllers, because most of it is more focused on the electronics and the design.
Yeah.
But when it comes to manufacturing, then this is where there are some loose connections, the wire harnesses which are playing a role, the connections are creating problems. All these things are coming. So my point is that holistically to reduce this, because industry is looking at it today at academic institutions or some research institutions, that to find a solution for this.
Yes.
So is there something this is being done currently on this?
In India, you see some Taiwan, German, Japan, you go in some areas, they are very strong. As an Indian, we are strong in which field? Computer programming software. That's all. Madam's project got accepted because EV term is there. That is why government has approved this project. Yes or no, ma'am? Many application has reached to the AICTE, but why it has been approved? People should do research on EV. So now DST, other organizations, they are planning, if someone is working on power converters, blindly will accept his project. But I have seen many, as I said, many universities, you are telling spike, power electronics problems, other things, whether universities are working on that? No, because they don't have subject at all in that. No advanced control techniques, nobody is studying. Only basic, some power electronics, one subject basic they are having, and that is also half of the syllabus. Because analyzing all mathematical derivation, all these things, they will, mathematics, remove it. Because students are getting failed in that subject. So that is the problem. So in India, we are not strong in all this power electronics also. Toshiba, ABB, all this German, Japan, these people will work for that. So that is the problem. So that gap, who is fulfilled? Our university will fulfill. These IIT, NITs should work on this field. But no professor is taking interest, because if I am choosing this field, I cannot make good publications. If I am not getting good publication, I will not get promoted. If I am not getting associate to professor, then why should I choose this area? Better I will choose optimization technique, power system, or some other area where I will get number of publication and my promotion will be early. So that is happening. I said, no, one of my friend, he did his IIT Delhi, he did his PhD in electric vehicle. He searched many companies here and there. Finally, 7 years he took to complete his PhD, but he is not happy. Because what he planned, he could not complete, because industry support is required for everything. As sir said, 12 years I am running my electric vehicle. But things are not happening accordingly. So now that is why this in Atal FDP, all this DST SOR, if you are applying a project on this field, there is a 90% chance to get that project. And in India, we don't have collaboration with industry. Industries and institutes should work together. But that is not, we don't have such policy in India. But if you see Texas or Stanford, all this, they have started with industry and finally they reached as an institute. So that is.
And I have one more. See, now slowly, the motor technology is moving with. Generally now they use Hall sensors for communication. Now somebody is also thinking that we should not have sensor because these Hall sensors are also creating problems in the field, failures of that. So then if the motors are without the sensor.
I'll tell, sir. Drives are two type of advanced drives are two type drives. One is sensor drives, other one is sensorless drive. Sensor drive means suppose you are using any mechanical sensors like speed, torque you are sensing, that is a mechanical sensor, that is called sensor drive. Sensorless drive means you are sensing voltage and current. That is called sensorless. If I am sensing speed and finding speed converted into voltage, that voltage is compared with reference voltage, finding the error, there is a delay. But sensorless means I am measuring the voltage. Voltage is that is 50 Hz, 20 millisecond only. Whatever I am sensing also 50 Hz, 20 millisecond, I can compare easily. But sensorless drives need a high powered DSP processor to do this. So working on that is very difficult. If it is mechanical sensors, my system will work like your old vehicle. If it is not starting, you just push it, put the gear, it will start and will go. Somehow it will. But nowadays electronics, if your brake is not, that sensor is not working, your scooty will not start. So such problems are there. So nowadays sensorless drives has come. The BLDC motor, inside the BLDC motor you have the inverter. Just you give 3-phase supply, it will take care of everything. Hall effect sensors are there. So it will give all Hall effect sensor 3 coils, 101, all these things it will sense and it will work on. But whenever we are going for heavy vehicles, then our magnets are not that much advanced. Permanent magnet will not withstand.
Two-wheelers, three-wheelers.
Yes, that is fine. For heavy vehicle like buses and all, it's not possible. Any other questions? Or Anthony, you can send to my mail. Okay, I'll be happy to answer any questions. Okay.
One small question.
Sir.
Multi-level inverters, in one of the project you have shown, you have used 5-level inverters.
Yes.
Is there any restriction, like if you go to the 7th level, it will be more difficult or not that easy, or you have started from 3rd, then you have stopped?
What my student he did 5 level, then did 7 level, did 9 level. He has done the comparative analysis of all these 3. He found that the harmonic percentage, total harmonic distance is 1%, 2% only differ. Cost, more switches, complexity is more. So then he finalized that 5 level is best. Okay.
Power electronics, motor design, control of vehicles, and those who are working in this field, it will be very much helpful for all. I hope all the participants have enjoyed the session. Thank you very much, sir. It is an eye-opener session at the beginning of that. Now, I'd like to request Dr. Usha ma'am to present a memento as a token of gratitude.
For the whole day.
Thank you.
Okay.